ಇದು ಚಾಲು ಮಾಡಿ ಅದು ಗಂಟೆ ಬಂದ್ ಮಾಡ್ರಿ.
Hi. Good evening, everyone. So today we have to go with the concepts which are related to the physics. Now here, guys, we should know what is the meaning of physics. So here, physics, P-H-Y-S-I-C-S, the physics. The 7 letters which will explain about how physics looks like a funny. And everybody is thinking that the physics is one of the toughest subjects and it is little bit just like a hard nuts. But according to my view, it is the funniest language and it's the funniest subject. If we are getting into it, that will going to be explained, that will going to be use a much more sweetness towards the knowledge. And now let's begin with this. The 7 letters of the physics. The 7 letters of the physics, what it explains. What is the meaning of this physics? Guys, just to remember here, P stands for. So this letter P always going to be says that there is a footstep forward. It's a footstep forward. It means we are going to be having a lot of problems, lot of trouble, lot of fearness, which is related to the so many concepts. So for example, why the sun is going to be having such a glowing character? Why the moon is going to be only shines at the night? And why the means to know about this concept, to get the idea regarding with those concepts. So first we have to look out about our first step. So that is, we have to be the form. We have to put our step forward. Once if you put our step forward, then we are going to be having a lot of hesitations. So H stands for it's a hesitations. What is the hesitation? Can I do this? Can I go for this? If I read the physics, I can become a gentleman, I can become a very great person. Like so many hesitations. So if I'm going to read the physics, can it going to resolve all the problems associated with so many problems which are related to the universe? Like so many hesitations which will come across in our mind. And those hesitations with a first step, if I put with a very bravery, and then hesitations will be goes off. Once our hesitations are goes off, then we are going to be capable of saying the yes. It means we are going to be having such a capacity, an idea, and there is a skill which is going to be tells about that. Okay, you can do this. We can achieve this. Okay, we can go through this one. I can do this better and better. Like that, so many yes things will be explained by this word as a why. Then after saying yes, the third letter, which is going to say that yes, then the fourth letter, which suggests that word, and the searching and success. The 2 meanings we are going to have here. The one here, the searching something new. We are searching something new. What we will search? Imagine if I am going to be do this. Imagine I am going to be having this marker. What I am going to search? If this marker is converted to me, simultaneously it will be going to use a 2 color. How it will give 2 color? Why not the 3 colors? Why not 4 colors? Like so many searching ideas I have to research. Once I can search the ideas, then this is going to create and develop some IQ. My IQ will develop, my intelligent quotient ratio will be developed. Once the IQ will develop, then our career will become a golden career. Once the career will be the golden career. And of course, you know very well, success is running behind everyone. That is we call as physics. These 7 letters. See, this is we we call as the 7 magical letters. The 7 magical letters which will going to be change the whole life of a person who is going to read this. So what is 7 colors? Sir, we know that the 7 colors of the rainbow, the 7 colors of the rainbow is because of what? Scattering of light. Again, it's an amazing fact which is related to the science. Challenging to the science various aspects, challenging to the various technological concepts, challenging to the various pandemic situations, and the solutions we can get only through the various skill-oriented programs and various skill-related ideas. Through this, we can solve that. So 7 letters which are going to be formed as what? And a rainbow. The rainbow. When you see the rainbow, when you see the rainbow, how the rainbow is looking like? It's once the person is going to watching the rainbow, so he will feel always happy, and his soul and his mind will be feeling as happy. Oh, how beautiful this rainbow! How is beautiful? How it's going to be after us? So curious, the curiosity among the matter, the curiosity along with that ideas, which creates and we know more about the concept of the physics. Then after this, what will happen? After this, he is going to be running just like a horse. See, we know that the power we are required to analyze, we are required to understand the concept that power is generated through inbuilt. That is because of what? And physics. Then lastly, it will going to be develops a huge amount of knowledge. That knowledge will create and creative ideas for creating so many things. And nowadays, we are going to just facing so many problems because of this pandemic. Guys, you remember, we are facing so many problems which are related to this pandemic, but even this pandemic situation has been created so many new ideas, has been developed new views, which is related to the how to lead your life. Of course, it's going to be having a panic situation, but even under this panic situation, we got so many new innovative ideas. How to survive. The survival things which makes us to build our career. Of course, and now we back to the main point of this chapter, that is what we call as the physics is going to be running only behind. There is a 2 important concept. The one concept that is we call as the first important concept is the energy, and the second one is the matter. And we know that what is a matter? First, we should know what is a matter. So matter is the one which is going to be having its own mass. Just first point we get there is a mass. Yes, mass. And it occupies the space. See here we know that mass. What is a mass? How to get this mass concept here? Mass we can define generally in normal language. It's a density is equals to mass divided by volume. It's a mass per unit volume. In normal situation they are defined. But we are talking about this mass. This mass is equals to density into volume. For given volume, how many quantities of particles or atoms or molecule can situate, and that leads to their mass. It means the quantity of a matter that contained inside the body. This is we call as a mass. This mass is going to be generally we call as a scalar. What is a scalar? Again, we have there is a physical quantity. Normally, we can call this one as a physical quantity. It is physical quantity. What is a physical quantity? A physical quantity is the one which can be easily measured. So this is we have a pen. Okay, the length of the pen I can measure, and now we can having there is a cap and the length. The corresponding diameter we can easily measure. That is what we call as a physical quantity. Anything which can be easily measurable. So now here, this quantity I can measure so easily. And among those measuring quantities, it is divided into 2 types. One is called scalar, another is called as a vector. Yes, this is vector. Scalar having only magnitude. These will have the only magnitude. So we can get a simple example for the scalar quantity. The best example for scalar quantity is the mass. Best example for this is the mass. The second one is called as a length, and third one is called as a time. These are the best examples to know about these are the scalar quantity. But they doesn't have any particular direction. The direction is not present for those things. The direction is not associated or not linked with these parameters or these quantities, and those are called as a scalar quantity. For example, let's imagine. So here I have there is a 5 kg of sugar. So 5 kg of sugar I have. Among this 5 kg of sugar, if I add 2 more kg of sugar, so this will gives you what? Again a scalar quantity, not a vector quantity. It is a scalar. So 2 plus 5 is going to give us a 7. So 7 kg. So kg is an unit. Kg is a unit, and this is a numerical or a number. So without a number, this unit is meaningless, and with this unit, the number will going to produce a meaningful result. The addition of 2 scalar always gives you a perfect scalar. So now, this is we call as the addition of scalar quantities there, and we can go for a simple algebraic method. The simple algebraic method for this is what we call as the addition or maybe subtraction. Addition or maybe subtraction. This is simple algebraic method which will suggest that how we can add and how we can subtract, all those things will be obtained from the scalar quantity. But whereas, just to remember, guys, remember here we have this vector quantity. This vector we can't add so simple it is, because this vector is going to have both magnitude as well as direction. It is going to be having both magnitude as well as the direction. So we can't add this one with simple algebraic method. We have an advanced method of addition of 2 vectors. That is the first one is called triangle of vector addition. The second one we have parallelogram of vector addition. So these are the 2 important methods. They are applied for add the vector quantity. Now we go to the best examples for this vector quantities. The first best example for this is the displacement. Displacement. The best example, displacement. The second best example for this vector quantity is the second one is a velocity. Velocity, etc. We can call these are the best examples which is related to the vector quantities. Now here, our main topic, which is mainly discussed, and we are mainly dealing with this, here is the motion in a 1 dimension. So let's begin with this, the motion chapter. That is what we call as the here we go with the main topic, that is we call as the motion in 1 dimension. So here, what is exactly the meaning of a motion in 1 dimension? Imagine a car is moving. A car is moving on a straight road. So this is the car we have, is moving on a straight road. Can I call this is 1 dimension? Why not 2 dimension? Why not 3 dimension? Why only this is called as 1 dimension? 1D. So about this information, which will be explained in this topic, that is the main branch of the physics called as what? And mechanics. It is we call as a mechanics. The mechanics is the branch of physics. Branch of physics. It is a branch of physics. It mainly deals with the study of. It mainly deals with study of. It mainly deals with the study of bodies. Bodies, or we can call as the particles. Bodies or particles are at rest. Or you can also call this one as a under motion. As we can apply the technical term for these two. for anastatics. Rest stands for statics. Motion stands for dynamics. Motion stands for dynamics. Statics in case of solids. Statics in case of solids. In case of solids, it is going to be called as what in normal language we are using as a statics only. But in case of this static, in case of liquids, we call as a hydrostatics. Hydrostatics. Hydro stands for liquid. Because of that reason, they are applying as a hydrostatics. And the statics in normal we can call in terms of solids. And for liquids, we call as a hydrostatics. But in dynamics, for the liquids, we can call as a fluid. Fluid dynamics. Dynamics. For liquids, for applied information, I am using the word as a fluid. Fluid is nothing but what anything which has an ability to flow. So remember, this will going to be having an ability to flow. That is we call as a fluid. So we are thinking that flowing means two characters we have. One is for liquid. Liquid is also having an ability to flow. Second one is the gas. Together we call as a fluid. So these two together we call as a fluid. Dynamics again we call as a motion. We call as a motion. And that's why. So here liquids and gases together are called as a fluids. Now this whole things which is related to the mechanics part, and now we are talking about there is an kinematics. Kinematics. So here kinematics, have you just written in shortcut, remember? So kinematics, remember the word kyna related to there is a kinetic energy. Okay, so this is kinetic energy. The meaning of kinetic energy is motion. The meaning of this kinetic energy we are going to be expressing in terms of as a motion. Matics is stands for mathematics. It's a maths. Applying mathematical equations, applying the mathematical terminologies, applying the mathematical situations, whatever linked to the motion of the body, that is called as a kinematics. For example, imagine if a car is going to move it, say for example, u is equals to 10 meters per second. So here, I am using the notation as a u. U stands for the initial velocity. See, this initial velocity of the car is 10 meters per second. After certain distance, say for example, it has to move from point A to point B. It covers certain distance. So here, so say for example, 8 meters it has to cover. Say for example, just imagination purposes, I am giving this example. Just understand. A to B, there is a distance to be 8 meters. Then the car may cover certain distance from here to here, from A to B. Then final velocity V, they have to be calculated. But how do we calculate these things? That's why we are connecting so many mathematical equations, so many mathematical formulas, which is going to tell us about how the distance, displacement, velocity, speed, acceleration will relate to each other. Then all things will be discussed in this motion in one dimension. Then what is a motion? Let's deal with one by one. What is a motion? We can define the motion so precisely and simple manner. Motion is nothing but what? And a changing the position of the body, or you can call as a change of position of the body with respect to time. It's a change of position. Change of position with respect to time. This is defined as a motion. Here, to go with this motion, so how many types of motions we can find? In a day-to-day life activity, we find different types of motions. So remember, when we switch on the button, the fan will rotate. Imagine this is an axle we have, and these are the plates of the fan we have, and this fan will rotate in circle. Can I call this a motion? Yes, of course it's a motion. So this is we call as a circular motion. This is circular motion. It is we call as a circular motion. A small cake, imagine, say for example, this is a small cake, it's going to be standing like this way, and this is a horizontal surface. This is a horizontal surface. And it's going to be having a ball. Say this is a ball which is going to be having, and this ball is going to be thrown by head. It covers a distance like this. And this is we call as a motion. Yes, of course, it's a projectile motion. We call as a projectile motion. So next one, sir, how many types we can mention according to the motion chapter it is? We are going to define three types. One is rectilinear motion. The first one is called rectilinear. Rectilinear motion. So rectilinear motion. What is the meaning of a rectilinear motion? Rectilinear means it's always we call it a straight line motion. It is straight line motion. A body moves in a straight line. A body is always tends to move along a straight line. Is called as a rectilinear motion. Is also called as a linear motion. We call as a linear motion. Linear motion. We call this one as a linear motion. Now begin with this. So how you define this? This is expressing by using rectangular coordinate geometry system. So among that, see, this is we call as a coordinate geometry system. So this is x, this is y, this is z. Representing them, if the body is going to take it from the origin to O, out of three coordinate geometry system, it has to move possibly any one direction. So for example, say for example, this is A to X, the body is moving here, and this is kind of one dimension. Out of three, it has to move only in one possible direction. This is we call one-dimensional motion. One-dimensional motion is the one in which out of three coordinate geometry system, it has to move only one possible direction. That is we call as a one-dimensional motion. It is. Example, we know that the best example, a person is moving on a straight road. This is one dimension. A car is moving on a straight highway is the best example. A train is moving on a straight track is the best example for one dimension. These are all considered in what? In one dimensional motion it is. Then followed by the second one is called as a two-dimensional motion. The two-dimensional motion is called as a motion in a plane. It means respectively two coordinate systems we have taken. So that example for this is projectile motion. A small pebble. A kid is going to be holding a pebble. Imagine Imagine this is we call as a pebble. Okay, this pebble is along with the horizontal surface. Imagine this is kind of a horizontal surface, and here there is a pebble behind. And this pebble is been thrown, so it covers a trajectory path. This is kind of a trajectory, and we call this trajectory path as a parabola. This trajectory path, whatever is covered by the small pebble, is called as a parabolic path, and this parabolic path is going to be covered by the body, is called as a two-dimensional. Then among that third one is called as three-dimensional. But the three-dimensional, they are discussing the three-dimensional motion of a particle or three-dimensional motion of a given body will be discussed in the best way that is called as kinetic theory of gases. In the kinetic theory of gases, we are discussing about the three-dimensional. How would I say? The motion of a gaseous molecule. The motion of a gaseous molecule is random and it will move in all possible three directions. This is we call as a three-dimensional motion. The best example for this is three-dimensional. Now to connect with these motion in one dimension, we have to go with the basic terminologies which is related to the one-dimensional motion. The first terminology we are using as a distance. The first terminology we are using as a distance. The second terminology we are using as the displacement. The second terminology. The third terminology we are using as a speed. The fourth terminology we are using to deal with this motion in one dimension, that is called velocity. The fifth terminology we are using, that is called acceleration. These are the 5 terminologies we are using to deal with this motion in one dimension. Among the first, we have to go with the distance and displacement. What is a distance? So distance is always called as a scalar quantity. Distance is called as a scalar quantity. It's a scalar quantity. and displacement is called as a vector quantity. This is scalar and this is vector. How it can be defined? Imagine, let's imagine. So here, this is the point A. This is we call as an initial point. We call as an initial point or a initial journey. Say this is xi. X is the position. We are taken as an x as a position. I is the initial point. It means xi stands for initial position of a particle. So this particle is taken here. Then to move this particle, so we have three possible directions. The three possible way to reach the another end, that is called as a final end. So I can reach, so for example, so here I'm just standing from the board here, I'm standing this end. I can go with this. This is the one possible way. The second one, I can just move from here to edge to the here and again from that here. This is the second point. Either I should move in zigzag manner. That's the third way. Similar to this here. So this is the one straight way possibility we have. The first shortcut way is we call as a shortcut way. So this is the second point we call. Say this is B. This is second point. And then go forward. Next one is, so here this is we call again the displacement we have here to move the same. And one more point, and here there is we got the one more point. These are the three different ways. So to reach the second point. So this point is like as a final point. And this is we call x, the final position. Now we can define. See, this is the one way to reach the end B. And the second one is the one to reach the point B. And this you can see there is a zigzag path we have. But see this one. Distance is the one where actual path covered. This is also actual path covered. Yes. It is actual path covered. But whereas the displacement, this is we call as a shortest. It's a shortest path covered. Now we have one question in our mind. Is this distance, is the distance is always going to be equal to the displacement, or is this lesser than the displacement, or is this lesser than or equal to the displacement? Like so many questions we have. But always remember, this distance is always greater than or maybe equal to the displacement. But it's always, remember, distance is not less than displacement. This is not possible, but this is the right possible conditions we have. So hence, now we can define, so this is the actual distance and this is the shortest. Then we have so many questions which is related to how does distance and displacement associated with the body can be calculated. And now imagine, here we have there is a find the ratio of that. Now we have a small question for the distance and displacement here. Find the ratio of distance to the, find the ratio of distance to the displacement for a given body. Imagine, so this is the point A we have. And this is the point B, where the body will reach in the another end. And it has to cover a semicircular path. It has to cover or it has to move from semicircular path. The radius will be taken as a R. The radius is taken as R. Then we have a ratio. We are talking about the ratio. So ratio is equals to what again? Here is the distance. Distance divided by displacement. So total displacement from A to B is, just imagine this is, we have the one total displacement from here to here will be R, and this is R plus R is equals to 2R, is the total displacement. And for semicircular, so for a semicircular, total circle means this is total circle, the value will be 2 pi R. Half of this will be getting us what? And a pi R. Then substitute this value for the ratio, we get there is a pi R divided by 2R. R will get cancelled, we get there is a pi by 2. So here, the ratio associated with this type of motion of a particle in a semicircular path condition is pi by 2. Then work on the second example. Here we can go with second example. Let's imagine a fly there. So here we have a fly. So this house fly, imagine this we can call as a small house fly we have. Okay. This house fly is moving in a queue. So this is we have a queue. So here in the queue. So this position will be taken. So here the point, initial point is taken as A, and there you can find there is a fly. Okay, this fly is going to be situated here and is covering the distance from A and here. So then here, then it will be here, and it will reach the point B. Then calculate the corresponding displacement of a particle here, and calculate the corresponding displacement associated with this fly. How we can calculate from this? So this is we call as a body diagonal. So here, so this is we call as a body diagonal. So this will be going to gives you about the displacement of this fly. So this value will be root 3 times of A, where A stands for and a size associated with the cube. So therefore, this will be obtained now. So this is the corresponding second best example to know about there is a displacement mean. Then third one, if a particle is going to move in a circle, if a particle is moving in a circle, say for example, if we take it from the point A and it has to move from A to, so this is the radius to be considered, and then it will reach us to the point B, then the shortest distance, so this is we call as the shortest distance. Okay, then we have to calculate from this end, so this is R and this is O. Then we have to calculate this value, but taking the shortcut method it is. But how do you take the shortcut technique? So you know that according to Pythagoras theory. So this is 90 degree. So we have this 90 degree angle. So we know that this is AB is equals to under root of, this is R square plus R square is equals to under root of 2 times of R square is equals to under root of 2 times of R. This is AB. This is we got that. And this is the shortcut. And one more simple formula, which is vectorially, we are going to adding the two vectors. Through that we can also get it. What the simplest formula it is? So this is displacement is equals to. We can write displacement D is equals to. It is 2 sine square theta by 2. So this is 2 sine square theta by 2. So this sine theta by 2, sorry, it's a sine theta by 2. So then once you apply the condition sine 45, we get this sine 45 is root 1 by root 2. So into R is the corresponding radius. And then we can get it D is equals to. So how we can get 2 into sine of theta is 90 degree by 2 into R. So 2A, instead of A what we taken as R is the 2 into sine 45 degrees into R. So this is 2 into 1 by root 2 into R. So 2 can be written as root 2 into root 2 divided by R. Sorry, into root 2 R. So this 2 will be cancelled. Root 2 times of R. So this is the formula we are going to obtain from vector additions. But how we get this? Say for example, by using the Taylor method. Say imagine we consider the two vectors. So this is vector A. Say for example, this is R2 vector. Say this is vector R1. The angle between them will be taken as theta. This is R1 is the first vector, R2 is the second vector, and then join this one. So this is the corresponding displacement. We taken that. The shortest path which is covered. Now imagine always it is always taken from when two tails will be meet. When two tails of the vector will meet at one point, then only they produces an angle. Otherwise, no angle will be obtained. This point should be remembered. Then, if it is going in a straight line, so then I can write this one as a vector R1. Then D will be in the same direction. See, the tail is going to manage over here plus vector D is equals to, but it is moving when this is going to meeting at this point, taken as minus of, plus of vector R. 2 it is. Therefore, vector D is equals to vector R2 minus vector R1. So this is the displacement. The result is how do you get this? By taking this modulus of D is equals to So this is under root of r1 square plus r2 square minus 2 times of r1 r2 into cos theta. And if both vectors r1 and r2 is equals to r, then both vectors will be taken. The radius will be considered as the same. Corresponding radius will be taken as same for this. Then we can substitute over here. Then displacement is equals to under root of what we get here. So this is r square plus r square minus 2 times of r square into cos theta. So this is under root of, this is the 2 times of r square minus 2 times of r square into cos theta. We just look out here. This is both terms are constant. Then take outside. We get here under root of 2 times of r square 1 minus cos theta according to trigonometric functions. So this is 1 minus cos theta gives you 2 times of sin square theta by 2. Then substitute what you get here. So this is equals to under root of 2 times of r into 2 times of r square into 2 into sin square theta by 2. Then simplify this, 2 2s are 4. So it's under root of 4 under root of r square into under root of sin square theta by 2. Square will be cancelled. 2 times of r sin theta by 2. You remember this formula from this vector addition method. So by using this vector shortcut method, we prove this formula. From this formula, we can solve any numerical which is associated with any one of the problem. Such type of problems will be solved. Okay, we have one more example for this. Imagine in a circle, this is the point where we consider the particle A is moving. It starts from its journey from the point A. It has to cover certain distance, see here, and it has to reach at this point somewhere. You can consider anywhere. I am taking this point as a B. Then it makes an angle of 120 degree. Theta is equals to 120 degree. Then the corresponding radius will be r. Then apply the shortcut method. The shortcut method already proved. That is what we call. So this is the shortcut method. The displacement associated. Say shortest distance. This is we call as the actual path covered by the body, and this is we call as the shortest path. So this is d is equals to, or you can call as a AP is equals to. D or median is equals to, it is 2 times of r into sin theta by 2 shortcut. So 2 into r into sin 120 divided by 2. 2 ones are 2 6 are 60. 2 times of r sin 60. Sin 60 is a root 3 by 2. So this is, we can get the answer once again. So this equation which suggests that the corresponding value which is related to the given displacement condition. And one more best example in shortcut method, remember, if it is exactly moving from the point, so this is the point to consider as a A, this is the point as a B, point A, and this is the point B. Then it has to move from this end. What is the total displacement? It is the total displacement from here to here. So this is R and this is R. The total displacement is 2R. This is a way to understand the concept of distance and the displacement. Now we can remember what is the major difference between the distance and the displacement. The distance and the displacement, the major difference between these two, it is a scalar and it is a vector quantity. It is a scalar and it's a vector quantity. And this distance is always called as shortest. Distance is called as the actual path covered, and displacement is called as the shortest path. So these are the way to understand the concept of time. There is a distance as well as the displacement. Now here we go with as earlier we have been proved, there is a cubical body problem. It is like this. There is a cube So this is the cube we shown. A fly is going to move from one end to another end. So this is the body diagonal we got. The answer we wrote as a root 3 times of A. But how do you get this root 3 times of A? Imagine if when the fly is sitting over this end, at this partner, the journey starts from this end A. Imagine from the corner, if you consider there is a corner of a room, if I consider any corner of the room where the body, the associated with the problem, the body diagonal. See here, A, B, this coordinate will be taken as 0, 0, 0, 3 coordinates because there is 0, 0, 0. And simultaneously, if it goes from this end, A to B, see, here to here, again here, I can write the corresponding value as an AI cap plus A J cap plus A minus A K cap. The meaning of I cap, J cap, K cap. What is the meaning of this? These are called as what? I cap, comma, J cap, comma, K cap. These are all called as unit vector. These we will call as a unit vectors. What is a unit vector? Unit vectors are the one which are going to be having only unit magnitude. Only unit magnitude is called as a unit vectors. Therefore, now we are applying this one. So how do you get this? So corresponding we can write this as a B. A and B are the corresponding short of displacement can be it. So here, so this is AB is equals to vector AB is equals to. So this is AI cap plus AJ cap minus this is A times of K cap. To get the corresponding displacement, we can write take the models. AB is equals to under root of A square plus A square plus A square is equals to under root of 3 times of A square is equals to under root of 3 times of A. So this is the answer we can get from this. So these are the understanding way to get the corresponding equations which is related to the distance as well as the displacement. Now the second concept or related to the equations related to the motion of a body, that is we call as the speed and velocity. Speed and velocity. So we have various types of speed and various types of velocities. The first speed is always defined as speed of a body, always defined as it is a rate of change of distance. Rate of change of distance. But whereas the velocity is rate of change of displacement of a body. Displacement. It means speed always dealt with the scalar, and hence velocity is equal as a vector. And now the notation of the velocity will be in vectorially is denoted as vector v, and here speed is denoted as a normally we can denote as a v. But vectors always denoted by vector denoted by arrow mark. Vectors always denoted by arrow mark. See, this is called as a tail. It only gives you about magnitude, and this will gives you about the direction. This will gives you direction. Arrowhead gives you direction, and the tail this will be gives you what and the magnitude. And that's why the meaning of a vector. Remember the word vector. The word derived from Greek language or a Greek terminology. The meaning is carrier. The meaning is carrier. It carries both. It carries both magnitude as well as the directions. That's the meaning of the vector. That's why speed and the velocity. The corresponding the speed and the velocity, which will be related by using so many parameters, that is we call as the initial velocity. Then second one we have the final velocity. These are the two parameters which will be taken as initial velocity as a u, final velocity will be taken as a v. And then the types of, okay, just a minute, I will just explain this. Okay, types of speed and the types of velocity. We have there is an instantaneous speed we have, Then the variable velocity we have. So uniform velocity, non-uniform velocity, we have the two different types of velocities there. The one is called as, first one is a uniform velocity. Uniform. The meaning of the uniform. Guys, remember, when we come to the school or college, everybody is going to just having, each and every one student is going to have the same uniform. Because that uniform will maintain the uniformity between everyone. And that not going to differentiate who is going to reach, who is going to poor, not like that. So it will maintain there is an equality. Similar to this, imagine a car. This is the called as a car. So just now we brought from the market. Okay, that's a funny purpose. Okay, this is the called as a car. This car is going to be starting this journey with a time, and it has to cover, say for example, 20, 40, 60, 80, 100. You see the distance corresponding covered by the car in every time. Say for example, T1 is equals to 4 seconds, T2 is equals to again 8 seconds, like that. So every 4 seconds, it has to cover 20 meters. It has to cover 20 meters. Then it means, can I call this a uniform? Can I call it as a non-uniform? Can I call it as a uniform motion of the body associated with respect to time? Can I call this? Yes, of course. Because it is going to move uniformly in a particular direction. So that is we call uniform motion, where the motion of a body with respect to time is same, is called as a uniform. And it covers equal distance. In normal language we can define. It covers equal distance in equal interval of time period. Is called as a uniform velocity. And whereas in other hand, we have non-uniform velocity. If the car is there, okay, this is the car we make it, and this car is going to be, for initial first 4 seconds it has to cover only 2 meters. The next 4 seconds it has to cover 25 meters. Can I call this uniform? No. Of course, it's a non-uniform. It is not going to maintain uniformity. Then we can call this one as a non-uniform motion. The non-uniform motion is the one in which the body does not going to be, or the body unable to cover the equal distance in equal interval of time, or it covers equal distance in unequal interval of time period. We call this as non-uniform motion. We call as a non-uniform motion. And that is the non-uniform. And this, if it is associated with velocity, it is non-uniform velocity. And if it is associated with the motion of a body, then it is called non-uniform motion. If it is associated with the motion of a body, then it is called as the uniform motion of a body. So these are the different types we are going to discuss in there. Then the next one. Here, the one which is going to be related to equations. Okay, the next here, the one which is going to be related to the motion of any particle. Simplest way to understand how each and every one particle is moving in a particular direction, how we can calculate the corresponding value. So to relate these information, we are going to be applying the equations of motions there. We are calling as a motional equations there. Among them, we have 4 important equations of motion there. The first one is called V is equals to U plus A. This is the first equation of motion. Then second one, it is S is equals to UT plus half of AT square. Third one, we call V square minus U square is equals to 2AS. And the fourth one is Sn is equals to U plus A by 2 into 2n minus 1. So this is the fourth equation. This is for n terminus, and this is the 4 equation. These are the 4 equations we are applying to check the equations of our particles, where the variables associated with the velocity, time, acceleration, which is going to be calculated only in terms of linear motion. These are called as a linear equations. Linear equations of motion. These are called as a linear equations of motion. But in case of freely falling body, imagine this is we have a tower, or you can call as a building. A small pebble is taken, it is thrown down. It is falling freely down. For freely falling body, where initial velocity will be considered as a zero. For free fall, initial velocity is considered as a zero. The next one, and now it is under effect of gravity. It is under the effect of gravity. Then substituting here, we can get in motion, equation of motion in terms of gravitation. We can get here v is equals to u plus g into t. Where initial velocity is zero, v is equals to gt. This is for gravitation. Second one, s is equals to s is replaced by height because the tower is going to be having the height as a h. S is replaced by h. It is h is equals to, this is 0 plus half of gt square, and we can write the shortcut h is equals to half of gt square. This second equation, which is related to the when the body is going to be falling freely under the effect of gravity with initial velocity as a zero. Then third one, we can get v square minus u square is equals to 2gh, and then v square is equals to 2gh. In terms of height we need, that is v square by 2g is equals to height as a h. That is the height of the tower we can calculate from this. Then in terms of velocity we can calculate v is equals to under root of 2gh. It's an equation we can obtain from this. Then here we get there is a nth second. For nth second it is Sn is nothing but what? Sn is equals to u is 0 plus g by 2 into 2n minus 1. So these are the equations we can frequently apply to calculate so many equations related to the motion. Then finally, so here, can these equations, whatever the equations I wrote, the four equations, whatever we wrote here, is these four equations are dimensionally correct or not? Is they going to be have the dimensional value as the same or different? Let's be going to one small example for this. Okay, so here first I will do it for v is equals to u plus at. Is this dimensionally proved correct? Answer is yes. Is this having the same dimensional values? We know the simple explanation for this. Where v is equals to, v is called as a velocity. Which velocity? We just remember. So this is final velocity. But normally we are taking from this as a velocity. Velocity is measured in terms of the SI unit is meter per second. Meter is the unit to measure the length. Second is the unit to measure the time. This is plus 1. If it goes to the numerator, then it becomes lt to the power minus 1. So lt to the power minus 1 we got. Then initial velocity v once again, it is lt to the power minus 1. Acceleration. Acceleration a is equals to what again? It's a meter per second square. lt to the power plus 2, lt to the power minus 2 we got. Then time t is equals to seconds. The second is denoted by capital T. We got all the dimension values. This is 1 in length minus 1 in time, 1 in length minus 1 in time. This is 1 in length minus 2 in time, 1 in time. Substitute all the values in the equation for us to get the dimension values. This is v. V is equal to lt to the power minus 1 we got equals to u is again lt to the power minus 1. Then acceleration is lt to the power minus 2 into t to the power plus 1. So this is lt to the power minus 1 plus l into t to the power minus 2 plus 1 because bases are same. When bases are same, power must be added or maybe subtracted. We get here lt to the power minus 1 is equals to lt to the power minus 1 plus lt to the power minus 1. Hence, you see here, on the LHS is always equals to RHS. It means there is a principle of homogeneity. The homogeneous units you can find on both the LHS side as well as on the RHS side. This proves that both dimensions associated with the unique physical parameters or the any physical quantity which will be equal, then this is called as a perfect equation. This is we call as a perfect equation. That's it. So this equations, whatever we are obtaining from here, there is a v is equals to u plus at, the first equation, v square minus u square is equals to 2as, then s is equals to ut plus half at square, sn is equals to u plus a by 2 into 2n minus 1. These are the four equations which has been included here dimensionally. Guys, okay, hope you enjoyed the session. And there is one more important point we have to discuss. And there's one point that is in the next class we are going to be discussing about. There is the equations of motions, and there is a graphs. The important point of this chapter about the graphs. So we have the different types of graphs over there. The first graph we call as a BT graph. BT graphs. BT graphs. Then next one is a PT graph. PT graphs. Then AT graph. So BT graph, PT graph, AT graphs. The meaning of BT is a velocity versus a time graph. What the variation we can get? That is velocity versus time graph, position versus time graph, acceleration versus time graph. We have to calculate about these things. Then what is the meaning of a graph? What is the graph? What is a graph? The graph means what? And we are talking about the graph. Hey, how then what you did in your regular classes? What is a graph? They are going to ask a question to the students. The graph is nothing but what? How gradually or how linearly his studies are going to be getting upgraded. That things will be calculated here. Same way here, graph is nothing but what? And pictorial representation of a constant to the variable. Constant to the variable is called as a graph. For example, I will go to simple one graph it is. So this is the two coordinates we take. This is we call our x-axis. X-axis. To plot any graph, to plot any type of graph, we have to be follow the important point. The two important points. The one is always constant. That is called as an independent. Independent values always taken along x-axis. Independent values taken along x-axis. And variable or dependent values always taken along y-axis. These 2 points always you have to remember. So then you can plot any type of graph. Either it may be velocity versus time. Here you can just remember time is variable because the time depends on velocity depends on time. Time is equal as a constant because you can measure the time in Gulbarga as now it is 6 o'clock, but in Bangalore you can just measure is it 6 o'clock or 6:30 now? It's 6 o'clock only. It never going to change. It will remain same. Okay, same similar. It is the time is an independent, velocity is a variable, like that. So if I take the 4 second, 5 seconds, 6 seconds, 8 seconds, 9 seconds, 4 meter per second, 8 meter per second, then 16, like that, so many things. And then you can plot the nature of graph if it is going to be just moving from the origin, then it is called as a perfect graph. Because it satisfies the equation of a stated y is equals to mx plus c. This is the perfect graph. Then you can calculate the slope of any point. Will use the same. The slope always gives you same value in this type of graphs. Then in the next class, guys, hope you enjoyed the session. So in the next class, we go with the various forms of the various methods, the various techniques, the various analysis, which is based on the various techniques, various methods, which is related to the how to plot a. First, we go with the VT graph. Second is the PT graph, AT graph, and how to apply the equations of motions. All things will be drawn there successfully. Okay. Hope you enjoyed. Thank you.